Construction projects can be seen in almost every city in America. Unless you work in this industry, the average individual is not aware of the many varied aspects of construction. For TTL, their role in construction includes geotechnical, analytical, and environmental services, all which are linked to geological science. Located in Tuscaloosa, TTL works with their clients to implement cost-effective programs for construction challenges posed by construction site conditions and geotechnical restraints. In layman's terms, they ensure that the land is fit for construction, as well as creating foundation designs to ensure that the structure being built is sound. When we visited TTL, they were working on one of their latest projects, Denny Stadium. There I met Bryan who explained to me what they were there to do.
We test concrete, we test soil for streets. We got what they call compactions. You got to make sure it's compressed the right amount. Asphalt testing. We want to make sure that it's meeting the job specifications that was written out for this particular job. What we did was what they called a slump test, which is what we consider workability, how it's flow with that concrete, when they work with it out on the job. We had an air meter, and trapped air. We wanted to see how much air they had. And like I said, all that revolves right back to the job specs. They call out how much air do they want for this job, how much slump they want for this job. And then we did, in most cases, 4 cylinders test specimens. We break one at 7 days, 2 at 28, and we hold one just in case it did not meet the compressive strength. And that's what we do with those.
While on the work site, we performed a slump test. So we loaded some concrete in a wheelbarrow and took it to the staging area for testing.
All right. Make sure we get in here.
All right, so we're at our home base then, right?
Yeah, we got 15 minutes to get everything you see right here done. We got to do, what Brett got there is a slump cone. We do it in 3 layers, and we use this rod. We gotta go 25, what we say blows, but it's really strokes. 25 strokes, each 3 equal layers. And that happens for everything you see here with this is what we call an air meter. This concrete's got so much entrained air in it. We check it, make sure it's in with specs. These are 6x12 cylinders, of course. We're gonna make our specimens off of this, and we're gonna break them later on in the week.
Okay. All right.
And what he's done is we also check the temperature. They have requirements on it. We start pushing 95 degrees. We got to get with our contractor and say, hey, what's the limit? We need to start making changes. You don't want to have hot cement out
there. No, sir.
With the slump test, it involves mixing, measuring, and analyzing to ensure that the concrete mixture has enough air according to the job specs. This has to be done fairly quickly because the concrete will begin to cure.
So do you have to read the specs, or?
We do. We do.
Okay.
We're knowing each column, if they got a certain mix design, PSI 4,000, maybe 5,000, we want to know if the concrete truck comes out here, well, 5,000, 4,000, we need to know that. So we know each column what their design mix is for. We're there to check to make sure it's the right mix.
And that's why you're here.
That's why we're here.
After the slump test, Bryan took us out to another one of TTL's work sites. At this site, a new road was being constructed. Bryan explained TTL's involvement in this project.
And you told me, but I guess, what am I trying to figure out right now with what we're doing? What is this going to tell you ultimately?
Percent compaction.
Percent compaction.
How compact did they get this material?
And that's going for what reasons? For water drainage? I mean, what could it be for?
Stability. You don't, if they would have come in here and just throw dirt in and we lay asphalt on it, you just have a bumpy road.
This process requires operating a drive pin, which Bryan explained and showed me how to operate.
We're going to pull the pin out. We won't be able to do
I'm not fixing to take off like a rocket anywhere.
Oh, no. You're fine.
And what is the name of this machine?
That's not even a machine.
It's not a machine. It's just a...
That's just a standard drive pin.
Drive pin, okay. All right.
You gotta pick it up, buddy.
Oh, I mean, just when we get down with it.
Drive about 8 inches is what we're looking for. That's good.
All right.
Now you just reverse, just pop it back up.
Okay.
There you go. Put a little meat behind it.
Yep.
All right.
All right.
Now you put your pin back in that top slot.
So I'm moving too slow for you and Brent. Y'all be done about 4 of these to my 1 over here. All right.
That part's done. Now
That
you
part's
got to get the gauge.
All right, we'll go get the gauge.
Once we drove the pin into the ground, Bryan placed a mechanism called a probe into the hole created by the drive pin. The probe measures the wet density and the moisture content. Bryan uses the data to find the dry density of a particular area. Because the probe is a nuclear source that emits radiation, not everyone can use it.
You know, it's a very minute, but it is a radiation machine. So just like you see the RNs in the hospital, stuff like that, are running X-ray machines, we have the same apparatus that we want to make sure we're not getting any exposure from the gauge, and we turn those in monthly by monthly, and just to make sure all of our technicians have been safe, or you know, make sure the gauge, and we do leak tests on these gauges every month to make sure there's no leakage too, so we take extra care with these gauges.
Okay.
Back at the lab, we met Mitch Clark. Mitch works as the lab manager, and he explained the testing done in the lab and why testing is important.
The lab here consists of concrete testing. We do all of the laboratory testing on the concrete cylinders and such that we performed in the field. And soil, we do all the soil testing here to just check for soil characteristics, make sure the soil's meeting project specifications and such as that. And then we use that laboratory data here out in the field, and we can compare results and make sure projects are being built as they're supposed to be.
Earlier, out in the field, we did the slump test. Now, back here in the lab, Mitch is about to show me one of the tests they run on those samples.
Here we are.
Right. So what's this room called, Mitch?
This is our concrete lab. We have a concrete brake machine here. Mm-hmm. This is what we use to determine the strength of our compressive strength of our cylinders. Okay. We have water baths to keep our cylinders at specified temperatures and constantly moist. Okay. Those are requirements of the test procedure.
All right. And we're about to test one.
Yeah, we will.
Okay.
We've got a nice little digital readout here. It tells us all the information. All we have to do is record it. These are our standard cylinders with neoprene pad caps, and we use these because when you break these cylinders, you want them to be completely perpendicular and have a plainness factor. Mm-hmm. Those are 2 critical things on getting a correct brake.
Okay. And when you say brake,
one that's reliable.
When you say brake, tell me what a brake means.
A brake is the compressive strength. Okay. We put the cylinder in here and load it until it actually fails. And where that failure is, that's where we get our maximum load, and then hence we can determine our compressive strength.
Mitch set up the machine by entering the size of the cylinder. The data received from this test will be sent to TTL's client, listing the PSI of that particular cylinder. As the amount of weight increased, the cylinder finally reached its limit.
I didn't expect that. You see it all the time.
Yeah. We have a wrap that'll go around it that'll prevent it from really just shattering like that, but it's always nice to see that happen.
Well, I mean, but is this what you wanted?
Yeah, that's exactly what you want.
You want to break this thing?
Yes. And then we'll record certain data here. You want to break these things at 990 pounds per second. We broke it at 920, so we were pretty close to our mark. 179,410 pounds, 6,350 PSI strength concrete.
Which is really good.
Really good concrete. More than likely, this job called for about 4,000 PSI, and it exceeded it by 2,300.
There's more to TTL's services than what we've seen today. There are several other testing operations and chemical laboratories housed on site to test a multitude of things. Additionally, their services reach further than just the boundaries of Tuscaloosa County.
Well, initially TTL stood for Tuscaloosa Testing Laboratories, but when the company grew and added a Montgomery office, they shortened that to TTL, and subsequently we've grown to Decatur, Alabama, and Albany and Valdosta, Georgia, and Nashville, Tennessee. But we have 4 primary service lines that we focus on. We do geotechnical engineering, which is soil and foundation investigations and design. We do analytical laboratory work where we test drinking water, wastewater, hazardous constituents. We do materials engineering and testing, and we do environmental consulting.
What is TTL known for right now? I mean, what's some of the big projects you guys are working on?
Probably the bigger projects that we're working on right now is we're doing the downtown convention center in Nashville, Tennessee. We're doing Bryant-Denny Stadium here in Tuscaloosa. We're doing the Archbold Hospital in Thomasville, Georgia. And we do the geotechnical investigation where we go out and take soil samples, design the foundations, give site grading recommendations to the designers, and then we follow up and subsequently do testing and inspection for quality assurance, quality control.
For people that are, in a community college system or even in high school and want to go into this type of work, what courses could they brush up on?
Well, typically you'll get specific training for each type of inspection or testing work that you do at a company like ours. But most of our field technical people have an associate's degree or a bachelor's degree in a science related field, whether it's an environmental science degree, geology degree, biology degree. We have a lot of chemists here that work in our analytical laboratory, and then we have registered professional geologists and registered professional engineers.
The Geological Sciences program at the University of Alabama shares an interest with TTL as it relates to working with the environment, from analyzing minerals and other natural artifacts to ensuring the stability of natural landscaping for major construction. The field of geology helps us in new discoveries, new technologies, and new earthly mysteries, which in turn helps our community grow.
If you have questions, comments, or suggestions about this or any other on-the-job program, feel free to contact us via email at feedback@onthejobtv.org or mail us at On The Job TV, 1 Technology Court, Montgomery, Alabama, 36116. Next week on The Job, we'll learn about the careers and educational opportunities in the field of biotechnology when we visit UAB's biotechnology program in Birmingham and Hudson Alpha Institute for Biotechnology in Huntsville. We'll also give you information on some of the job and training opportunities from around the state. That's all next week on The Job.